Hi, it's me again with another video. I just wanted to show real quick some changes I made to program 4 so that I could get it to work on my controller, rather on my simulator, since my controller is not working. First of all, I went into the kit again and I made some changes. Mainly I installed some of the things that I was going to need, such as the Baz22 web kit and the Baz22C platform, and I had to also install one called BazCC_NETV. Those were the three that I needed to install in order to have my program run just fine here in the emulator, even though it was created on the 22C and the emulator is for 22. Now the changes specifically that I made are that I obviously got rid of the physical input of the switch. That was my binary input number 1, and I turned it into a virtual switch which can be turned on or off here virtually. For the zone temperature, since I do not have right now a thermistor or a way to connect it to a controller, I went ahead and I use a ramp function block to simulate that. It's a triangulation what it's doing with a maximum temperature of 78, minimum of 62, and this goes to a round block that just rounds it and sends it to the rest of the logic. I still have then thermostat for cooling and thermostat for heating. They are both set with differential of 2 degrees, so they will start either lowering or raising the temperature once the temperature has reached 1 degree above the zone set point. Each one of the set points for the zone, it's an individual virtual point. So we have a cooling set point and a heating set point. Both of them are virtual, so those points can be found under the virtual points right here. You have heating set point and cooling set point. Right now the heating set point is 68 and cooling set point is 72, so there is a dead band of 4 degrees, although technically it becomes 6 because of the thermostat block here. The differential adds 1 degree in each direction. So here we see it. We have then 67 for the zone heating set point, and let's go through the logic of one of the two, heating or cooling. Well, here's the switch will be on, and the on will indicate that the entire system is working right now. I also got rid of the block that was going to my binary output 1, which was my fan, so my fan is not showing that it's on right now. But what I wanted to show mostly was heating and cooling, which is done in 2 stages: cooling stage 2, cooling stage 1, heating stage 1, heating stage 2. I added this other block here just to make it easier to see what the actual temperature is right now. It's only connected over there to the same ramp controller, and it gives us rounded what the temperature is. Currently 74 degrees. 75, it is switched. So right now the cooling just kicked in. We have cooling stage 1 on binary output number 2 would be true, so that would have triggered that relay and started the heat pump right then. The fan would have been working already. Now as it hits the 78 mark, the cooling stage number 2 will start working. The ramp is set to go to a maximum of 78 and then starts back. So as you can see, the air cooled off from there, and the air ramp simulates this by going down. So our our cooling stage 2 goes off, remains on only cooling stage 1. As we approach our cooling set point and we pass it by 1 degree, we'll see that our cooling stage 1 will also go to false, and there we have it when we reach 72 degrees. So now we're on dead band. We are no longer we're no longer cooling, and we are not heating yet. So we go down from the dead band, and again the dead band is going to go all the way to 67 degrees, which is when the effective zone heat set point is for 67 degrees. So here we are at 67 degrees. Right now we are at set point, so our differential says we need to get to at least 1 degree below that. As we approach that, we'll see it go on. There we go. We get to 65 degrees and we have our heating stage 1 go on. And then as it cools off, we will see the heating stage 2, here it is, go on. Now our temperature reaches the lowest maximum and it starts going up, and the cycle goes on and on. Again, how I calculated stages 1 and 2 was I added a differential here, just a constant float that says that if my temperature that the temperature differential between stages should be 3 degrees, and then a compare block, it's going to compare what my actual temperature is right then, or the temperature difference is between the set point and the actual temperature in the room. So that's what this is doing. This is subtracting the actual temperature in the room from the differential set point, and it's sending the signal to compare. In this block, it's comparing that signal to the differential and saying, do I need to start? Is it true or false? Do I need to start stage 2 heating or not? The same goes then right here. We'll see it with the cooling. We are going to compare. It'll say, is cooling necessary if it reaches more than, in this case, a differential is 4 degrees. So we can change this differential and set it to 3, and that way we'll have the same differential in both. And we are about to see it as the temperature changes, rises. Now they are the same. The block still senses that. Now it changes, and now we have 4 degrees higher temperature than the set point, and therefore we're going to have cooling stage 2 go on. The minute that lowers again, which we will see on our temperature, the minute that lowers again and becomes 3 or less, then our cooling stage 2 will go off and only cooling stage 1 will remain. Okay, those are the changes that I made, and thank you.